Morning, guys. I see some of you are there. We're going to start now. I hope you did the question. Before, there are two easy questions, but these important things for the June exam on paper 2. Okay. So we're going to start just in a minute. Waiting maybe one more minute. Waiting for one more minute to begin. There we go. Did you answer the questions? I hope you did. Just waiting one more minute. Okay. We're going to start just in a second. Okay. Was it difficult, Pamelo? Not really. Did you solve them? Okay, I think we can start, Pamelo. If the other people join, then it's fine. Otherwise, we move on. Yeah? So let's start with this question. The question says a few organic compounds A to E are represented in the table below, and then there are 2, 4, 5 compounds there. Okay. Now, if we look quickly and we find out the homology series, the first one is a haloalkane. You can see the bromine. In this case, you have like 2 halogens involved. The second one, you have an alcohol. You have the OH there, and now this carbon that is next to the maybe I should come here. This carbon that is next to the OH have 2 hydrogens, so it means this is a alcohol and not an aldehyde. We have an aldehyde, which is pentanal. We have a carboxylic acid, and we have here a alkene. Okay, that is important to know. We know the homology series of each of them. You can write it next to each compound. We have a haloalkane, alcohol, aldehyde, carboxylic acid, and alkenes. Those are the different homology series, which is important. Okay. Now, the first question says write the IUPAC name of compound A. Let me just write IUPAC name here quickly so we can see the answer. We have CH3, we have CH. Let me just write it here to show you how to do the answer. It should be fine. You all should have it. CHBr, we have CHBr, we have CH3. Okay, I'll show you just now. Trying to copy first. So here, this is the compound we have. All right, and we have to write the name of the compound. So the first thing we need to know is to find out the homology series to which it belongs. Remember, this is an haloalkane, and therefore will end in ane. Okay, so this one is like writing the data here. Right, then the second step, we have to look for the longest continuous carbon chain. This one is a straight chain, 1, 2, 3, and 4, so it's bute. There we go. It's bute. Okay, we look for the functional group. In this case is halogen, but remember, when you have a haloalkane, doesn't have priority which one you start to count. So either one, if you start from the left, we have carbon. This is 1, 2, 3, and 4. If you starting from the left, if you start from the right, you will have then this will be 1, will be 2, 3, and 4. So the halogens are in the same position. It means it doesn't matter which side you are going to decide where to start counting. So let's start from instance for the red one. Let me just move all these green one. There we go. So that is the counting we're going to use. So we have bromo in carbons 2 and carbon 3. Bromos are in carbon 2 and 3. So what we have here, I'm going to write 2. Now that 2 is the carbon in which this bromo is allocated. Okay, it doesn't mean that there is 2 bromo. This is 2 bromo. And we also have 3 bromo. You can see that bromo is in carbon 2, but here is also a bromo in carbon 3. All right, so now here we have 2 of the same halogens. It means we have to use a dibromo. So this one will be 2,3 dibromo. 2,3 dibromo. All right, 2,3 dibromo. That green is a little bit not good. Let me take it away and use another color. And then we combine. We have nothing else, so we combine the name. So the final name of this compound is going to be 2,3 dibromo but, that together in one word, butane. And this is the name of compound A. This one is for compound A. And that was question. Let me look for it here. Question 2.1. IUPAC name of compound A. Okay, so now the general formula of the homologous series to which compound B belongs. General formula of the homologous series. Now, what is compound B? We have to first identify the compound. Okay, we have to identify the compound. Compound B is an alcohol. I'm going to write it real fast here. Compound B, I'm going to write it down here. It's enough space to write B is an alcohol. That is the homology series. So to get the, we may try to fix this one a little bit. There we go. It's an alcohol. To get the general formula, we need to know the homology series. Okay. Now for that one, we are going to go to the lesson. That one was in one of our lessons, lesson 18. You can see there. You look for alcohol. The general formulas, all of them are here. You have to memorize them, and you will memorize them as you practice more. So the general formula for the alcohol is CN. I'm going to write it here. CnH2n plus 1 OH. That is the general formula for alcohols. All right, I'm going to show you now. It is right in here. That is the question. That is the solution. Here is the general formula for alcohol. Let me maybe move my face to this side here. Okay, there you can see it. There you can see it. That is the solution. This is coming from the question and it's coming in the lesson. That was lesson 18. In lesson 18, we have this table. I said use the examination guideline. Here is the examination guideline. The problem is in the examination guideline, you don't have the general formula. I recommend you to include here another, let's say a new column here in which you write the general formula for each of them all the way down. That it will help you to get the general formula and learn them. Okay, it's not a big problem. But let's go to the question. That was question 2.2, general formula of compound B. Question 2.3, structural formula of the functional group of compound C. Okay, so we're going to go there now to compound C. Now, what is compound C? Compound C is an aldehyde. Now, we once more have to come here to the examination guideline. We're looking for aldehyde. Aldehydes are here. This one is the aldehydes, as you can see here on this side here. This is the aldehyde. They want the functional group. So if we go back to the question, they want the structural formula of the functional group. You can see here, this is the functional group in a structural formula. So if you come back here, and we solve that one, for an aldehyde, this one is an aldehyde, all right, the structural formula of the functional group will be carbon, double bond oxygen, this is hydrogen. That is the functional group, the structural formula of the functional group of the aldehyde. This join here with the carbon is important. You cannot skip it out. If you don't have that line there, you don't get the mark. So it's important, guys. Okay, make sure you have that line in there. Okay, so that was question, I believe it was, let me check here quickly, it was question 2.3. Question 2.4, structural formula of compound B. Now we have compound B, which is 2-methylpentanoic acid. So 2-methyl, let me write it down here so we can actually answer. It's 2-methyl, 2-methylpentanoic acid. 2-methylpentanoic acid. That one is the question. 2-methylpentanoic acid. So now when you write the structural formula from the name, let me have a sip of coffee. The first, you do need to know the homology series. Okay, this one is a carboxylic acid, and then for the carboxylic acid, if you go to the examination guideline, if you are not sure, guys, go there to the examination guideline. In the examination guideline, you look for aldehyde and what is the functional group of carboxylic acid. What is the functional group for carboxylic acid? We have carbon, double bond with oxygen, single bond to oxygen, then hydrogen. That one is the functional group of the carboxylic acid in structural form. Okay, now important. This is carbon number 1. This is the first carbon. Okay, so you make sure you count that carbon as the first carbon. So we now have the homology series. We need to look for pent. Pent means 5. So you have 5 carbons, including the carbon here. So this is carbon 1, and I'm going to represent 5 carbons starting from there. So that one is carbon 1, 2, 3, 4, and 5. I'm going to start from the left. It's entirely up to you. For the carboxylic acid, it could be actually easier to start from the left. So remember that it's carbon 1, 2, 3, 4, and 5. Now we are going to go to the substituent. Where are the substituents? Let me see if I get here this color. We have a substituent. We have a methyl, and that methyl is in carbon 2. All right, so in carbon 2, we have a methyl. Remember, a methyl will be carbon that have 3 hydrogens. That is a methyl. Okay, this is methyl. And then that methyl is in the second carbon. Remember, the first carbon is this carbon, here is carbon 1, so this one is carbon 2. So you have to represent a methyl in that specific carbon. It doesn't matter if you do it top or bottom, doesn't really matter. I'm going to do it on top because at the bottom I have this word which I don't want to erase. So here you have a carbon, and that carbon is connected to 3 hydrogen. There we go. That is the 3 hydrogen. That is the methyl that is connected to this carbon. Okay, and then guys, the rest is to substitute the hydrogens. So here now we have all the hydrogen, and you make sure that every carbon have 4 bonds. It cannot have 3, it cannot have 2, it cannot have 5. It must be 4 bonds. And this one is question This one is a question. If I'm going back to the questions here, let me just go quickly. That was question 2.4, structural formula of compound the 2-methylpentanoic acid. 2-methylpentanoic acid. Question 2.5. There is the answer. So I hope you get it. I hope it's not difficult. I hope it's not difficult. You can ask questions, remember. Okay? You can ask questions there. All right? So this one was question 2.3. 2.4. 2.4. Question 2.4. Let me write it here. Question 2.4. 2.4. There we go. Okay? Question 2.4. Right, now the next one. The next question here. The next question say, let me just go to the question. The next question say, write the structural formula of a positional isomer of compound E. So now we go to compound E. Let's see which one is compound E in the question there. Okay. Now compound E, you can see is this compound here. Let me just write it down here. We have CH3, single bond CH, double bond C with a methyl at the bottom, CH3, but not in this way. I'm writing it in the board so I can answer to you. We have here CH3 and then it's CH3. CH3. There we go. There we go. So now this here is the compound E. This is compound E. Okay, I'm going to write it here. Compound E. That is compound E. Now they want a positional isomer. We go to the question again. Let me show you the question here. They say structural formula, structural formula of the positional isomer of compound E. Structural formula of the positional isomer of compound E. Now, positional isomer. What is a positional isomer? Positional isomer. Let's write it down here. Isomer. Positional isomer. What characteristic does a positional isomer have? They have same molecular formula. Same molecular formula. Important. Different. They have different position of functional group. All right. So the position of the functional group is different. Right. So now which one is the functional group in this specific compound? The functional group is the double bond. This one is A. This one is A alkene. The functional group is that double bond. So the position in which that double bond is allocated is going to change. And here we have two options. It can either change to the left or could either change to the right. It does not really matter. They don't specify, so either one will be a positional isomer of this specific compound. Okay? So now remember they have the same the same molecular formula. So let's represent first this part here. We have CH, CH3. We cannot change that one. We have CH. We have here the, I have to move this one a little bit up. There you can see it. So now I have here the C with the CH3. I'm going to write the CH3 on top. There we go. Okay, and then here I'm going to place the double bond. So I changed the double bond from this carbon to that carbon there. Okay, so here is going to be C, but instead of H3 is going to be H2. I have 2, 3, and 4. This carbon have 4 bonding. This one have 1, 2, 3, and 4. All right, but not the following. We have to be careful with the hydrogen because we remove one hydrogen from the first carbon. So now that hydrogen must come somewhere here. So this one is going to be CH2. All right, so now we make sure the molecular formula is the same. Very easy. All you have to do is to count here. So for the first compound, we have 1, 2, 3, 4, and 5 is C5. For the second compound here, which is the positional isomer, we have 1, 2, 3, 4, and 5. C5. Let's count the hydrogen here. We have 3, 4, 5, 6, and 7, 8, 9, and 10. So we have H10. This one is the molecular formula, which we say must be the same molecular formula for the first compound. For its positional isomer, if we come here and we count, we have 2 hydrogen plus 3 is 5, 6, 7, 8, 9, and 10. H10. These 2 compounds are what we call positional isomer. You can now, to practice, write the name of each of them. I'm not going to do it because of time. We already have 23 minutes going on in the stream, and I don't want to go too long, and we still have to go and mark the other question. So this one is the first question. This is the end. Is 8 marks. I'm sure you all can get those 8 marks. Now we're going to start with the second question, but you can see if there is any question. You can ask any question there. Okay, you can ask any question if there is. So we can start with the question 4. I'm going to wait for a second. I'm going to clean this one so long while you mark your work. And then we're going to start with the question 4. Okay. I move my face here, right in the middle there. Okay. Okay. So if there is no question, then I'm moving on. The question says organic chemistry is the chemistry of organic molecules divided into homology series, which are identified by the functional group. Define the term homologous series. Now to get homologous series, I'm not going to write it, but all you have to do is to come to the examination guideline. Here is the examination guideline. Homology series is here. Remember, you are only allowed to write the definitions that are in the examination guideline. Homology series is a series of organic compounds that can be described by the same general formula. Up until there, if you do that, you will get the 2 marks. You don't have to go to write the second O. They will give you the 2 marks, the 2 ticks that you actually need here for that definition. It's quite simple. It is in the examination guideline in page 16. If you go to the next question, consider the organic compounds. You always have certain organic compounds, and real fast. A is an alkene. You have a double bond. There. B is an aldehyde. Remember, let's go here quickly to the examination guideline once more. Look here. What we're looking for, we have here. This is the functional group. You can see the functional group, 1 carbon, double bond, oxygen. That is the functional group of this specific compound, okay? That one here is the functional group there. All right, so if we go here, we have carbon with double bond oxygen. If we have here, we only have 4 options. Those options are an aldehyde, ketone, carboxylic acid, or esters. Those are the only 2 possibilities in which you have a double bond with oxygen. All right, you can see double bond with oxygen, the carbon double bond with oxygen. It's difficult to write like this, but the characteristic of that compound is that you bond it to hydrogen towards the end. Therefore, hydrogen to the end, the only one that we have here is an aldehyde. So that compound is an aldehyde. See, you can see a Cl there. This one could be tricky if you think you're going to get confused through the structural formula for C. In actual fact, you can do it and see what compound is going to be. Because if you look carefully, you say haloalkane, but look at that one by yourself. D, now we have here, look here. These two look alike. They are very much similar, and if you don't look carefully, you can confuse these two compounds. You can confuse this one with this one here. What is the difference? What is the difference there? This carbon is connected to a oxygen, not to a hydrogen. So if we look back to the examination guideline, we have carbon connected to oxygen. It is there. No, I didn't want that one. I didn't want that one. Let me erase this one here. There we go. I didn't want that one. This carbon is connected to an oxygen there. Is the difference. This one is a carboxylic acid. It means if you come to the question, D is a carboxylic acid. Okay. Now, if we go, question 4.2.1, draw the structural formula of the positional isomer of compound E. We already spoke about positional isomer, so I don't think I have to go back and explain everything. We have X2-in. Draw the structural formula of the positional isomer of a positional isomer of compound E. If we have E here, compound A, pardon, this one is question 4.2.1. I'm going to write it here, hex 2-in. Hex 2-in. Let me go here so I can show you real fast. There we go. That is hex 2-in. Hex means there are 6 carbons. All right, this means 6 carbons. 6 carbon. All right, this is an alkene. You can see here all the double bond, the in. This one is an alkene. And then we have 6 carbon with an alkene, and the alkene is in carbon number 2. Okay, so we have 6 carbons. We have 6 carbons. 1, 2, 3, 4, 5, and 6 carbon. This is the compound. This is not the positional isomer. This is the compound. In the second carbon, there is a double bond. So the double bond must be there. That is the double bond. And the rest is just completing hydrogens. Okay, so let's quickly complete the hydrogen and make sure this is 1, 2, 3, and 4. 1, 2, 3, and 4. I'm going to do it at the bottom. It doesn't really matter where are you going to do that one. This one is the compound. This is compound A. Compound A. There we go. Which one is the positional isomer? You are going to change the position of the double bond. Change the position. The position of the double bond. It means you can place it anywhere, but not in the second carbon. So if you move it from there to this specific point here, it will be again the same compound. So the only two options are to move it here, move it there, or you can move it here. Those are the only two options. If you move it here, will be 3 in. If you move it here, will be 1 in. There are only two options. You cannot move it anywhere, because if you move it to the ends, it becomes like the number 2 again. Okay? So now where will be the positional isomer? I'm going to move to the first carbon. It may be the easier one, and then we'll see. So it will be carbon, double bond carbon, and then still, it must be the 6th carbon. 1, 2, 3, sorry, I moved this one a little bit. 3, 4, 5, and 6. 1, 2, 3, and 4. And then the rest is hydrogen. 1, 2, 3, and 4 here. There we go. Remember, you always have to count. Make sure at the end you have the same number of hydrogen and carbon. For the actual compound, which is compound A, we have 6. This one is C6 hydrogen. You count 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12. That is what we have. If we count for the positional isomer here, we have carbon 1, 2, 3, 4, 5, and 6. So it's carbon 6. I'm going to write it here. C6. We have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. H12. That is the positional isomer of the compound they are asking here. Now, the question say, draw the structural formula of the positional isomer. So you are not looking for the ideas. You are not looking for the name. You're looking for the structural formula, which is this one here at the bottom. This one is the answer of that specific question. Alternatively, this double bond can be, instead of here, could be there. Okay? Is another option. Those are the only two options you get here. All right. So moving on, so we can finish. Moving on, write down the structural formula of the functional group of B. B is an aldehyde, guys. We already answered this one. We already answered this one in the previous question. So I'm not going to write it, and we spoke about that. So it's an aldehyde, and the functional, the structural formula of the functional group is going to be shown here. Here is the answer for that question. Let me see if can I write it here. This one is a question 4.2.2. This one is question. Let me see if I can write. It's difficult to do it here. Question 4.2.2. This one is the structural formula of the functional group. This one is the name of the homologous series to which belong, that you can see they ask you to answer that one there. I'm not going to repeat it. We did it just before. Now question, the next question is question 4.2.3. They say write down the IUPAC name of compound C. So it's good because actually I did ask you to go through, but we have to answer them just now. Let me just clean here so we can write the name of that compound, IUPAC name of compound C. Let me just write the compound here. We have CH3. CH3, let me do it a little bit up. Right, CH3, CH3, CHCl, CHCl, CH2, CH2, CH2. Okay, CH3, CHCl, CHCH2. So let's then come now and do the structural formula. It may be easier if we answer the solve the structural formula before. So we have a carbon with 3 hydrogens. Then we have another carbon. No, don't combine the carbons yet. Leave the combining of the carbon for last, because they may be double or triple bond. So have all the carbon with the hydrogens and substituents, and then you join the carbons, okay? So we have a carbon with 3 hydrogens. We are here. Carbon with 1 hydrogen and 1 Cl. So we have here carbon with 1 hydrogen and 1 Cl. I'm going to write the Cl at the bottom. This one is hydrogen, this one is hydrogen. I say don't combine the carbon, and I just combined it. You see? I say don't combine it, leave it for last, okay? So now we go with the next carbon is this one. This one is connected to 1 hydrogen. And then we have another carbon with 2 hydrogens. 1 hydrogen there, and I'm going to draw the other one in here. Now am I going to combine the carbons. Remember, there's 4 bonds. So you make sure you combine the carbon to complete the 4 bonds. We have 1, 2, 3, and 4 when you combine this carbon here. We have 1, 2, 3, and then we need a bond here. So this carbon have 1, 2, I need 2 more. Those are going to be 3 and 4. So it means this one is an alkene, which do have a halogen. So it's not a haloalkane, but it's rather an alkene. All right, you have here chloro. There we go. So now let's write the name of this specific compound. Like we say always, we're going to do like data. What is this? You have the double bond. Double bond is an alkene. It's an alkene, so it's going to end in in. All right? There we go. Then we're going to look for the longest continuous carbon chain. This one is a straight chain. So you have straight chain is only one possibility, which is this one here. There we go. And we have 1, 2, 3, and 4 carbons. This one is 4 carbons. 4 carbons. It means it's but. It's going to be but. Let me write that one like a U. Don't you think it's A? I know you're struggling with my handwriting, even though it's beautiful. So is but. There we go. What you do then? You start counting the carbons starting from the end nearest to the functional group. In this case, the functional group is the double bond. So when we count the carbon, I'm running out of colors. When you count the carbon, you have 2 possibilities, left to right or right to left. So if we start from left, we have 1, 2, and 3. The double bond is in the 3rd carbon. But if you start from the right, we have 1, 2. So the double bond is in the 1st carbon. All right? So this one will be carbon 1, carbon 2, carbon 3, carbon 4. So when you do that one, you come to the double bond and you identify in which carbon is allocated. That one is in the 1st carbon. You can see carbon 1, there is a double bond with that specific carbon. So it's going to be 1 in. Right? So here we come in and it's 1 in. There we go. Now what we're going to do, we're going to add the substituent. In this case, we have the chloro. And the chloro is in carbon number 3. You can see the 3 there. So this one is 3 chloro. All right. So we have everything. Now we combine to write the name. The name is going to be the following. 3 chloro. 3 chloro, but, everything together. 1 in. This is the name of the compound. I hope you got the same name as I did. 3 chlorobut, 1 in. That is the answer. That is the answer for this question. I don't know, you can let me know if you didn't get that one or if there's something not clear in this specific question. Okay? And then we're almost done. We are very close to the end. Write down the structural formula of one functional isomer of compound D. Now, functional isomer. Let me just clean here. We're going to speak about that one real fast. It's always going to be there. Okay? It's always going to be there. Functional isomer. All right. So now the functional isomer, you need to know what are they. They are compounds that have the same molecular formula. They have the same molecular formula, but they will have different functional group. Different functional group. And guys, you have only 2 combinations. The combinations are aldehydes and ketones. It means aldehydes can be functional isomer of ketones, or the other way around. Those are functional isomer of each other. All right. And the other option that we have is carboxylic acid and esters. same story. Carboxylic acid could be functional isomers of ester or the other way around. So this is important. Now we go back to the question to see what compound are we dealing with. Compound D. Now what is compound D? Is a carboxylic acid. You see the functional group, we already spoke about that one. This one is a carboxylic acid. Look here, the functional group is carbon, double bond oxygen, oxygen, hydrogen. You go to the examination guideline, this is what we're dealing with, right here. This is what we're dealing with, okay? So now let's go back here to the solution. We have a 3-carbon carboxylic acid, okay? The compound, the actual compound is compound D, and it's a carboxylic acid with 3 carbons. 1, 2, and 3. Let me see, I want to make sure. 1, 2, 3, yes. 1, 2, and 3. There we have. And this one is the carboxylic acid. This is O, this is O, this is H, all right? This is compound D. We can see, yes, we can see everything there. This is compound E. This one is a carboxylic acid. Let's write it down here, down below here. Carboxylic acid. There we go. This one is a carboxylic acid, moving a little bit up there. That is a carboxylic acid. What do we say? If we have a carboxylic acid, we need to get an ester. So all we have to do is to convert this one into an ester. How do we convert that one into an ester? Let's look at the functional group of the ester. The functional group, look here, for esters. Carbon, double bond O, connected to oxygen, connected to a carbon. So that is the first thing I'm going to do, the functional group. The first thing I'm going to do is the functional group. So I'm coming here, and I have to move my face again out of the way. My beautiful face. There we go. Here we are. So now we come in here. Functional group first for the ester. Carbon, double bond oxygen. This one is oxygen, and then carbon. That is the functional group of the ester. Okay. Now, in here, we need 3 carbons. If you go back here to the question, we have 3 carbons. Here, we only have 2. We need another carbon. Where am I going to place it? Anywhere. It could be on this side or could be on this side. It does not really matter. It doesn't really matter. So wherever you want to place it, let's place it on the left. Let me see the question, or maybe they say specific and I didn't read properly. One functional isomer, so either one. So either one means that could be on either side. So I'm going to place it on the left, this side here. So I'm going to place the 3rd carbon there. And the rest, guys, what is it? The hydrogens. 1 carbon, have 1 bond, 3, 2, 3, and 4. This one is the completion of the hydrogens here. This carbon have 1, 2, 3, and 4 bonds. This carbon still need 4 bonds. 1, 2, 3, and 4. There we go. There we go. Okay? Remember, they must have the same molecular formula. So if we look carefully for this compound, let me write it here. This is like checking if the question is right. This one we have 3 carbons. 3 carbon, 1, 2, 3. Hydrogen we have 1, 2, 3, 4, 5, and 6. 6 hydrogen, and we have 2 oxygen, O2. Okay? This one must have the same one. 1, 2, 3 carbon. 3 carbon. 1, 2, 3 hydrogen. 4, 5, and 6. 6 hydrogen. 1 and 2 oxygen, O2. This one is correct. Guys, we are done with the question. I hope it helped. It's like having a private tutor because it's only you. So you can just ask questions now because we are actually done. We are actually done. That was the last question, 10 marks. Yes. So the only thing left here is if there is any question. If there is no question, then we are done. It's up to you. You just let me know. I'll wait like few minutes. Okay? Add the 2 to the hydrogen. What part exactly of the 2 to the hydrogen? I'm confused with the part. You add 2 to the hydrogen. Okay, what question exactly is that one there? 2 to the hydrogen. You have to tell me so I can move back and explain to you now. So you're confused with the part. I add 2 to the hydrogen. Now, what part? What question was that? 2 to the hydrogen. Eh? Okay, Kale, I'm waiting for you to tell me what 2 to the hydrogen, but what part? I don't remember. I told you that this is a delay, so I have to be patient. Eh? Or the positional isomer. Oh, or the positional isomer at the beginning of the questions. Oh, I see. That was question 4.2.1. Okay, it's fine. It gives me a second. I'll do it fast. It's hex 2 in. Hex 2 in is 1, 2, 3, 4, 5, and 6. Trying to fix this one, okay? Trying to fix this one for you to see it. Okay, we are here. Let me move it a little bit down. There we go. So we have 1, 2, 3, 4. Now this one is the compound. This one is compound compound A. All right. The one a positional isomer. I say we only have 2 possibilities, 1, 2, 3, and 4. We have only 2 possibilities. Okay, those possibilities are moving the double bond in this place or in this place. That is what I say. Okay, you cannot move it here. If you move it here, this one become the second carbon. So it will be the same. That is what we mean. So the option, let's say, for instance, you move this one to that carbon. So you will have, it's a 1, 2, carbon, 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 double bond here, carbon 1, 2, 3, 4, 5, and 6. No, this one is the answer. Let's say you move it there. Okay, let's say for instance you move it to this carbon there. All right, so if you do that, I'm going to answer yes now. If you by mistake did that one, then these 2 compounds are the same compound, because this one become carbon number 2. It's not completed. 1, 2, 3. This hydrogen. This one is hydrogen. If you do that one, what is happening is that this become carbon number 2. This one is carbon number 2, because the carbon you start counting for the double bond. You start counting from the side nearest to the functional group. So if that happens, then this become carbon number 2. So this one will also be the same compound. It will be hex 2 in. That is what I'm saying. It must be this carbon here, or it must be the first carbon. Those are the 2 options. If you move it to this carbon, you think it's carbon number 5, but it's not carbon number 5. It becomes carbon number 2. And then that is the explanation. I hope you got it. But guys, if that is all, we are done. Thank you for watching. I'll see you next time. Thanks a lot.